This one here has a linear factor and it has a quadratic factor. Note that x squared minus 1 would not be a quadratic factor because you can factorize it. But you can't factorize x squared plus 1, at least not in real numbers. So let's get rid of that. For the same reason, if you have something like x squared is actually a repeated factor, not a quadratic factor. So let's look at our linear factor of x plus 1. So we'll deal with that in the usual way for a linear factor. The quadratic factor we deal with by having bx plus c, so a linear factor on top of the quadratic factor. But then we do the same thing. We're going to go clear of fractions. So multiply right through by the denominator here, giving us 5x squared minus 2x minus 1. If you multiply this by this denominator, x plus 1's cancel, so you end up with a x squared plus 1. Note there's no value of x that's going to make that one 0, no real value. And the bx plus c would then be multiplied by x plus 1 because the x squared plus 1 would cancel. So let's let x be equal to negative 1, which gets rid of this one. So that would give me 5, no, x is negative 1, plus 2, take 1. And we know that's going to disappear. If x is negative 1 squared is 1 plus 1, so we're going to have 2a here. So this is 6 equals 2a, gives me that a is equal to 3. Now, I'd probably now progress by comparing coefficients. So if we look at x squareds, on the left we've got 5x squareds. On the right I have ax squareds from here. That looks a bit like a 6, so I'm just going to change that to a 5. And over here I'd have bx squared. And we know that a is 3. Which gives us that b is equal to 2. So there's just c to find, and maybe let's look at constants. On the left, I've got negative 1 as a constant. Over here, I would have a, if we expand this out, and I'd have c. b can't be involved in a constant because it's bx. So negative 1 is equal to 3 plus c, so c would be negative 4. So what we have is 3 over x plus 1, and then we would have 2x minus 4 over x squared plus 1.